Okay, we're going to do Unit 4A, the first part of Day 2. And I'm going to try to move kind of quick because this one, we got a lot to cover. And I don't want this to turn into like a 30-minute video, so I kind of want to move quick here. But our learning target, I can find sine, cosine, tangent ratios of a given angle on the unit circle. If you've never heard of that, we're going to explain what that is. Basically, it's just a circle where the radius is 1. So a unit, 1 unit, it's one. The radius is 1 unit. It doesn't really have inches or feet or anything like that. It's just 1 unit, and and it's centered at the origin. So that's the unit circle. We've been dealing with that the last couple of days. When we open up an angle, we start out going straight to the right, and we open up going counterclockwise. That's the unit circle. We've been using that. So recall what you learned in geometry about 30, 60, 90 triangles. So remember 30, 60, 90 triangles. So here's 30, 60, 90. And for these, the ratios of the sides. Okay, remember the ratios were, and for me, it's always kind of easy. 1, 2, 3. But it's 1, 2, radical 3. Okay, and if you have trouble remembering that, just think, if this is a 30, 60, 90 triangle, and if I butted up another 30, 60, 90 triangle right next to it, it'd be a 60, 60, 60 triangle. It'd be equilateral, so it'd be 2, 2, and 2. Well, if this whole side is 2, half of that is 1. So 1 and 2, and if you do Pythagorean theorem, you get radical 3 on the other side. So it's a 1 to 2 to radical 3 ratio. And then for a 45, 45, 90, a little bit easier to see. If it's 45, 45, 90, well, these two are going to be congruent. So they're both 1, and then do Pythagorean theorem, you get radical 2. So 1, 1, radical 2. So 1, 2, radical 3, and 1, 1, radical 2 is kind of the thing to memorize. So just look over these. In fact, just maybe try a few. Pause the video, and if you feel comfortable. If you don't feel comfortable, watch a few, and then pause the video and try it out. But this guy here, this is an 8. So it's a 1 to 2 ratio. This is going to be 16. And this is a 1 to radical 3 ratio. So if I multiply by radical 3, it'd be 8 radical 3. 45, 45, 90, if it's this 5, that's 5. And this is going to be multiplied by radical 2. So 5 radical 2. And if we're going backwards, we divide by radical 2. So this way multiply, this way divide. Here, if we're going this way, multiply by radical 3. If you're coming back, if you know this one, you try and find that one, divide by radical 3. Okay, and so on. So here's a 45, 45, 90. I'm going to multiply something by radical 2 to get 9. So that means divide it. So it'll be 9 over radical 2. We don't like to leave a radical on bottom. So we're going to rationalize that, which means you multiply by radical 2 over radical 2. So 9 radical 2 over 2. And this one is the exact same because these are congruent. This one here, I got this, the altitude here. If that's 9, remember this was multiplied by radical 3. That means I got to divide by radical 3. So 9 divided by radical 3. Well, if we're going to rationalize that, that'd be 9 radical 3 over 3, which actually simplifies to 3 radical 3, because 9 and 3 would reduce. And then to find this side, double that. So 6 radical 3. If this is 12, divide by radical 2. Okay, rationalizing would be 12 radical 2 over 2, which would be 6 radical 2. And this will be equal. And this guy here, there's the hypotenuse, so that's 15. This would be 15 over 2. And to find that third side, multiply by radical 3, so it'd be 15 radical 3 over 2. Okay, so we're going to be doing that a lot. Okay, hopefully that rang a bell from geometry. Something else that should ring the bell from geometry, and sorry this is small, but if you really look at it close on your paper, you can probably read this a little bit better. We've got the sine, cosine, tangent, SOHCAHTOA. Well, also, for sine, there's also cosecant. Okay, so cosecant, which right there is the spelling of that, cosecant, it's actually the reciprocal function of sine. And then secant is a reciprocal function of cosine, and then cotangent is a reciprocal function of tangent. It's literally just the opposite ratio. So sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Okay? So let's look at theta here. We got theta, and then we got this W up here. We'll just call that W for now. So let's look at theta for now. This first table is all about theta. Okay, so the sine of theta, that's opposite over hypotenuse. Opposite over hypotenuse. 4/5. Now the cosecant is just the reciprocal of that, so 5/4. Cosine adjacent over hypotenuse, so it'd be 3/5. Secant 5/3, flip it over. Okay. Then tangent is opposite over adjacent, so it'd be 4/3. Well, the cotangent is going to be 3/4. Let's just flip it over. Just flip that guy over. Now this one, I want to look at the other. I just gave it a different name. Here's my other angle. From this one's perspective, cosine is going to be different. It's not going to be 3/5, so I'm talking about a different angle. So this is adjacent over hypotenuse. That's 4/5. The cosine of this angle is actually the sine of the other angle. It's all about perspective, what angle we're looking at here. The sine, I'm going to jump to sine, that's going to be opposite over hypotenuse, so 3/5. Notice the sine of this one is the cosine of the other one. Then for cotangent, I'm going to look at tangent first. So in my head, I'm going to do tangent. So opposite over adjacent, so TOA, opposite over adjacent is 3/4, flip it over, 4/3. Okay, and then secant, this is hard because a lot of people, they associate secant with sine and cosecant with cosine because they sound, they begin the same. It's not the case. So secant is the reciprocal of cosine. So I'm going to look at the cosine of this. So adjacent over hypotenuse is 4/5, that'd be 5/4. Okay, try to get good at that. Try to get good at doing those. Sine, cosine, tangent, and then now cosecant, secant, cotangent. Okay, now the unit circle. Let's do some work with unit circle. Here's a unit circle centered at the origin. The radius is 1. So this is 1 to the right, 1 up, 1 down. I'm sorry, 1 left, 1 down. So, you know, these coordinates right here, this would be 1, 0. And this would be 0, 1, and so on. Just those coordinates of those points. Now we're going to look at the measure of this angle, you know, a theta of pi over 6. And when it says pi over 6, that indicates that it's in radians. And remember, if we just want to get an idea of what that is, you know, because our minds can't really wrap around opening up pi over 6 radian. But we're pretty good at degrees. So just think of pi as being 180. So 180 divided by 6 is 30 degrees. So this is a 30-degree angle, which means it's one of our special 30, 60, 90 triangles. So 30, 60, 90 triangles. And what we're doing essentially is we're trying to figure out here the sine ratio of this 30, which when we do that is basically, let's see here, it's going to be how far to the right we're going. The sine ratio is also how far to the right the side is. So the sine, well, let me fill in that stuff here too. So this is a 1, because the hypotenuse is always 1 since it's a unit circle. So if this is 1, this would be a half, and this would be, multiply that by radical 3, so it would be radical 3 over 2. So essentially, I'm sorry, not to the right. I said how far to the right we need to go. It's actually how far up, because this coordinate, see the sine ratio, it's kind of weird how it works out. It's actually the sine is actually the y coordinate of this point. So anyway, let me get to this. So the sine ratio is kind of get back to what we were thinking. Maybe ignore what I said so far. The sine ratio is opposite over hypotenuse. So a half over 1, well, anything divided by 1 is itself, so it'd be 1/2. Now the cosecant, just flip it over, it's 2. Try to keep it simple. We'll find these, and I lined them up so that the reciprocals are aligned straight across from each other. And you make sure you remember which one goes with which on your own at some point, but right now I've got them lined up to be opposites. The cosine ratio is going to be the adjacent over the hypotenuse. So radical 3 over 2 over 1 is just radical 3 over 2. Flip that over, that's 2 over radical 3. Rationalize it, 2 radical 3 over 3. And then tangent is going to be the opposite over the adjacent. So 1/2 over radical 3 over 2, which if you notice, that's just 1/2 over radical 3 over 2. That's actually the same thing as the sine over the cosine, kind of what we just did. Okay. Now, if they're both over 2, we can, when we flip and multiply, when I multiply this by 2 over radical 3, the 2's cancel out. So if you just want, the shortcut here is if the bottoms, if the denominators of both of these match, just wipe them out. It's actually 1 over radical 3. Rationalize that. That's radical 3 over 3. Okay. Now, okay, my computer ran out of space, so it stopped recording. I didn't realize it, but luckily this is all we've missed. Now, so I got radical 3 over 3. Now I could flip that over, 3 over radical 3, and rationalize it. But since these are equivalent, I'm going to take this one, because it would be over 1 when I flip it over, and it's the same thing. So kind of shorter that way, save yourself a step. That's up to you. Okay, so let's go to the back side. Do this kind of quick. I guess I want to make make sure this video is not a half-hour video here. But I got pi over 4. You think to yourself, okay, pi over 4, what's that as a degree? So take 180 divided by 4, or 90 divided by 2, which is going to be 45. So it's a 45-degree angle. Perfect. It's a 45, 90 triangle. This is a 1, so that means this would be 1 over radical 2, which when I rationalize that, it'd be radical 2 over 2, and this is going to be radical 2 over 2 for this side, which means the coordinates of this are actually radical 2 over 2, comma, radical 2 over 2. It's going to be the coordinates of that point right there. Okay? So the sine would be opposite over hypotenuse, so radical 2 over 2. The cosine is the same thing, it's adjacent over hypotenuse, so radical 2 over 2. Flip those guys over, that's 2 over radical 2, which is 2 radical 2 over 2. A lot of 2's involved there, but that's going to be radical 2. Well, so is this one, because the reciprocals of these are the same, the reciprocals are the same, so I can save some time there. And then the tangent is the opposite over the adjacent, which you can notice is the same thing as sine over cosine. So it's radical 2 over 2 divided by radical 2 over 2. Now, these are the exact same things being divided here, so that's going to be a 1. Okay, so the ratio is 1, which if they're the same thing, because tangent is what's the ratio of this side to that side, well, they're the same thing, so it's a ratio of 1. Now, if you flip 1 over, the reciprocal of 1 is 1. Okay, pi over 3, again, pi over 3, so think pi as 180 degrees, 180 divided by 3, it's going to be 60. It's a 60-degree angle, makes us a nice 30, 60, 90 triangle. Well, nicer than the one I drew. There must be something under the desk or something. It's getting wavy here. After my draw, it's wavy. But there's right angle. If this is 1, that means this is going, let's see, this would be 1/2, and this would be radical 3 over 2. And notice this coordinate right here then is going to be right 1/2 up radical 3 over 2. So that's the coordinate at that point. So the sine ratio is opposite over hypotenuse, so radical 3 over 2 over 1, so I'll just leave it as radical 3 over 2. Cosine is adjacent, so 1/2 over 1 is 1/2. Let's flip these guys over, so it's going to be 2. Flip this guy over, it's going to equal 2 radical 3 over 3. And then the tangent ratio, again, I can do opposite over adjacent, or I can just look at the fact that tangent is the same thing as sine over cosine. I'll put this in here. It doesn't really matter as long as these match. You know, the pi over 3 are all the same. You could always just put sine theta over cosine theta equals tangent theta. So I could just look at this divided by this. So radical 3 over 2 divided by 1 over 2. And I told you, if they have the same denominators, just cross them out. So radical 3 divided by 1 is just radical 3. Flip that over. It's going to be 1 over radical 3, which is radical 3 over 3. I'm not sure why I'm circling them, but there I did. So there's our answers. Something I want to point out, it's kind of easier to see on this one, but 1/2 was actually the cosine, and radical 3 over 2 is actually the sine. So it's almost like these coordinates, the first coordinate of that point is your cosine ratio, the second coordinate is your sine ratio. We typically say sine first, sine, cosine, tangent. I just think on the unit circle it's alphabetical. Cosine comes before sine, so it's going to be first. Okay, next one, pi over 2. Okay, so pi over 2, think pi is the same thing as 180 degrees, so 180 divided by 2 is 90. This is a 90-degree angle, so it's going to be straight up. It doesn't make a triangle. Okay, it doesn't even make a triangle at all. So I'm going to kind of use the idea of the coordinate of this point more than anything. So this coordinate would be 0, 1. That's cosine sine. And this 1, the sine ratio, remember sine is always over hypotenuse. So the opposite side is 1, and the hypotenuse is 1, and that's where we're getting 1 from that. The cosine ratio, the adjacent side, is 0. The hypotenuse is 1, because the hypotenuse is always how long that line is. That's hypotenuse. This is the hypotenuse. Okay, which just equals 0. So when I go to, the only reason I'm putting the denominator in is when I flip them over. So 1 over 1 flipped over is still 1. 0 over 1 is 1 over 0. That's undefined. So that's the first time we had an undefined ratio, because you can't divide by 0. So the secant ratio can't be found here. Now tangent, because it's hard to see opposite and adjacent sides here, it's not even a triangle, that's where I'm going to look at sine over cosine. So this equals sine over cosine. Sine is 1, cosine 0, that's undefined. So there is no tangent ratio either on this one. But the cotangent, flip that guy over. This is 1 over 0, flip it over, 0 over 1 is 0. So that does exist. The cotangent ratio does exist. Okay? And now, 2 pi over 3. So think 2 times 180 divided by 3. Type in the calculator if you want to, if you're not good at doing it in your head. I'm not good at doing things in my head like that. But I get 120. So this is 120 degrees opening up this way, which means you're actually 6 degrees short of all the way across there. So this is going to be a 30, 60, 90 triangle over here. So here's 60, here's right, here's 30, because this is 120. So together 180 degrees. Okay, so if this side is 1, then I can go 1, 1/2, and then radical 3 over 2. But I have to be careful here because right is positive, left is negative, because I'm also on a coordinate plane here. So this is actually negative 1/2. I'm going 1/2 to the left, and then radical 3 over 2 up. So this would be negative 1/2, comma, radical 3 over 2. Remember, that's a cosine, that's the sine ratio. Okay, and I can start filling things out now over here. So this would be, the cosine ratio is negative 1/2. The sine ratio is radical 3 over 2. Flip those guys over. That'd be negative 2. And now the tangent, again, it's just simpler to think of it as sine over cosine. So radical 3 over 2 divided by negative 1/2. Wipe out the 2's, so it's radical 3 divided by negative 1, so negative radical 3. Flip it over, negative 1 over radical 3. Be negative radical 3 over 3. Okay? So now we kind of want to get you to use this tool called the unit circle, using the ideas we just went through. We just did several examples, and hopefully we're kind of starting to think about the coordinates and the idea that the first one is the cosine, the second one is a sine. So you probably noticed that we could find all values from the quadrant 1 values. Maybe you didn't notice that, but we'll show you that here in a second. So look at the unit circle below and fill in all the sine and cosine values for these major angles that we marked off. So I got these, 12 spots. I'm actually going to add a few more. 12, 13, 14, 15, 16. And what it is, if these main 16, if you can do this, zoom out a little bit here, if you can do this, when you get to calculus, it's going to help you so much, especially on the AP exam. There's a non-calculator portion. If you haven't already known this, maybe you already know this from hearing talking to other people. And they'll give you things like, they'll say, what's the sine of 5 pi over 4? And you don't have a calculator. You can't put it in the calculator. You can't do the problem unless you can find that ratio. So the unit circle helps us out here. And it's all about patterns. And if you're in an honors pre-calc class or honors trig class, you're probably really good at patterns. You didn't make it this far without being good at patterns. So, keep in mind, the first coordinate is the cosine, the second one is the sine ratio. So looking at these guys, first off, 2 pi would be all the way around. So this is going to be, over here is 1 pi. This would be a half a pi, so pi over 2. This would be 3 pi over 2. Okay, now pi over 2, if I do half of that, this guy right here is going to be pi over 4. And then this one would be 3/4 pi, so I'll say 3 pi over 4. And then I got 1. I just keep adding a fourth for all of these. So let's see. Whoops, wrong one. Ignore that line for a second. We're doing this line, doing the middle ones. Okay, so a fourth plus a fourth plus a fourth plus a fourth. So 1 plus a fourth would be 5/4, so 5 pi over 4. And then another fourth would be 6/4, which is 3/2, and then 7/4, so 7 pi over 4. Again, that gives us those main ones, and this one we're just going to call 0. 0 or 2 pi. It's up to you how you want to label that. And then the other ones now, we're going to break it up. These marks then, to get, if this is 1 pi, this would be a 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. So each of these marks I haven't done yet are 1/6. So here's 1/6, so pi over 6. Here's 2/6, which would be pi over 3 if I reduce it. 3/6, which reduces to pi over 2. Here's 4/6, which is 2 pi over 3. And then 5/6, which is 5 pi over 6. Okay, and then we just keep adding 6th after that. This would be 6/6, 7/6, 8/6, which reduces to 4/3, 4 pi over 3. So 8, 9/6, which reduces to 3/2, 10/6. Sorry, I said it so many times, it's starting to sound weird to me. You say a word over and over, it starts sounding weird. So 10/6 reduces to 5/3, 11/6, which does not reduce, so 11 pi over 6. So these are the critical ones, these are the important ones. And really, these are also the ones that make special right triangles. Every one of these points make a special right triangle, besides these, on each one of those straight up, straight down, straight left, straight right points. Coaxial would be the word I'm trying to think of. But anyway, so this first one, and there's going to be a lot of writing going on here, so I kind of want to, I don't know if I'm going to organize this. I might have to change colors a little bit, but if I look at this one, think of that triangle right there. This is a pi over 6, which is 30 degrees. These are always 1, because this has a radius of 1. Okay, so this is 1. So this would be a half, and this would be 1/2 times radical 3. So this coordinate right here is radical 3 over 2, comma 1/2. Okay? Now it should be noted that this is a 30, 60, 90 triangle. Over here, this guy right here is also a 30, 60, 90 triangle. So it's going to have the same sides. It's going to be these values, it's just the x value is going to be to the left. So this would be negative radical 3 over 2 up 1/2. So that's going to be that coordinate. So this would be the cosine and the sine ratios. And if you need tangent, put sine over cosine. If you need the reciprocal function, flip them over. So all the information you need is right here in the unit circle. Now this right here is also a 30, 60, 90 triangle because it just got flipped over. So it's still going to be left radical 3 over 2. It's just going to be down 1/2 now. This one over here, it's going to be still right radical 3 over 2, but it's down 1/2. If you kind of get what I'm going at here, fill in the rest. Okay, if you're still stuck, watch me. Okay, so you can fast forward if you're kind of seeing the pattern here. Now I'm going to look at this guy right here. So pi over 4, if you remember from the front, that's a 45, 45, 90 triangle. So this one is, let's see if that's 1. This would be 1 divided by radical 2, so it would be 2. I want to go right radical 2 over 2, and then up radical 2 over 2. Well, this is also a 45, 45, 90 triangle. It's just going to be left. So it's going to be a negative radical 2 over 2. Going down, it's another 45, 45, 90 triangle. It's left and down, so they're both negative. And then this one right here, flip it over. It's going to still be right radical 2 over 2, but it's going to be down, so negative radical 2 over 2. So we set up here, if you have the quadrant 1 values, you can find the rest. Just kind of flip it and switch in the negatives, up, down, left, right. This guy here, so if I'm looking at, maybe if I draw this in with a different color, this triangle right here, pi over 3, that's a 60, so it's a 60-degree angle. So if that's 1, that's a 1 right there. This would be a half, which means I'm going to go right 1/2, and then up 1/2 times radical 3, so radical 3 over 2, which is really just this one flipped. Look at these two. They just switched their sine and cosines, because if you're talking about different angles, if you're talking about 30-degree angle, cosine's one value. If you're talking about the 60, it's a different value. So they just flip-flop. This one over here is going to be left 1/2, but still up radical 3 over 2. This one right here is going to be left and down, so left 1/2 and down radical 3 over 2. This one's going to be still right 1/2, but it's going to be down radical 3 over 2. So it's going to be negative. So anyways, it's off the chart. So all those can be found just by finding these guys right here. Now this point right here, just think coordinates. Don't even think sine, cosine. Just think the coordinates. This is right 0, up 1. This is left 1, up 0. This is right 0, down 1. And this is right 1 over 0. So I'm going to put that in like that. Okay? So now I got this unit circle. These are easy to answer. Okay? So the sine of pi over 4, we'll find 5 pi over 4, it's right there. And cosine sine, so that's negative radical 2 over 2. Cosine of 5 pi, well, that's not on here, but every time I go around, it's 2 pi. So 5 pi would be the same thing as 3 pi, which would be the same thing as pi. So if you're circling around there, so I'm going to go to pi, and then the cosine is the first one, so negative 1. 8 pi over 3. If you think 8 pi over 3 is more, if you divide that, that's more than 2. So I want to subtract from that 2 pi, which would be the same thing as 6 pi over 3, because 6 pi over 3 is 2 pi. So now I get 2 pi over 3. That's where I need to go. So 2 pi over 3 is right here. I want the tangent ratio, so I'm going to go sine over cosine. So radical 3 over 2 over negative 1 over 2. Cancel out the 2's. Negative radical 3. Sorry, I keep getting off the page when I do that. So, yeah, sine over cosine. So, in which quadrants is the sine function positive? Well, think sine is like the y-coordinate. When's the y-coordinate positive? Up, so 1 and 2. In which quadrants is a cosine positive? Remember, cosine represents the x, so when x is positive, that's to the right, so it would be 1 and 4. Whoops, 1 and 4. When is a tangent positive? Well, the tangent is going to be positive when sine and cosine are both positive or when they're both negative. So they're both positive in quadrant 1. When are they both negative? When you go left and you go down, so that'd be quadrant 3. Okay? So this is a lengthy video, but this is so stinking important, this unit circle, and you should be able to produce this on your own. You know, and even if you're just thinking of one angle itself, you could just do one of these, find the coordinates, and you're good to go.